Hello everyone, welcome to Engineering Archives. In this video we are going to do the first practice problem for this chapter, dot product. So the question says, determine the magnitude of components of the force of 600 newtons acting along and perpendicular to segment DE of the pipe assembly. So this is our force of, let me just change the color. This is the force F, and this is the pipe assembly. So the pipe assembly is going to act like an axis, and wants to find the component for this force parallel to this axis, and also the component perpendicular to this axis. And notice that they mentioned the word magnitude, which means they want us to find the magnitude of the components and not the vectors. And whenever magnitude of components is involved, we look at our formula number 4, and that formula says that the magnitude of the components is equal to the dot product of the force vector and the unit vector in direction of the axis. Okay, and this gives us the magnitude of the component parallel to the axis. So let's write down that formula. So the magnitude of the component parallel to the axis is equal to the dot product of the force with the unit vector in direction of the axis E, D. Okay? So for this formula we need, first of all, we need the force vector F. So let's find that. In order to find the force vector F, we will go through the regular procedure of first finding the length vector EB, and this vector is going to be negative 4i, negative 3j plus 2k. Now that we have our length vector, we will find the unit vector in direction of the force. With its magnitude. And this would give us negative 4i, negative 3j plus 2k divided by under root. Okay, now that we have our unit vector, we can get the force vector by simply multiplying the unit vector by the magnitude of the force, and that is 600 newtons. So 600 over under root 29 multiplied the unit vector. So now that we have our force vector, we can move on to find the unit vector in direction of the axis ED. To find this unit vector, we will do the same procedure. First, find length vector in direction of ED, and that is, we can see from the diagram, that is negative 3, 3. That's it, since this axis is parallel to the y-axis. Now we can find the unit vector ED by dividing this by magnitude, and its magnitude is going to be sum of square of components, but that would simply give us negative 1j. So now we have all the vectors that we need. Okay, so let's find the magnitude of the parallel components to the force vector by taking the dot product of the force vector F so this is the force vector F, and taking the product of this with the unit vector in direction of ED, that is negative j. And once we multiply all of this, once we multiply the respective x, y, and z components, actually let me just simplify this into one more step so that it becomes easier for everyone to understand. We have to do 400 4 under root 29 negative 1800 4 under root 29 j plus 1200 under root 29 k. And this is dot product with negative 1j. This is the first step. And once we multiply the respective x, y, and z components of the two vectors, the magnitude of the component parallel to the first f is equal to 1800 for under root 29 for under root 29. Actually, let me just write down on this next page. Negative 1800 for under root 29 multiplied by negative 1. I'm not writing down the products of the x components, x and z component for the force F, since those are just going to multiply by 0, since the x and z component of the unit vector are 0. So all that we are going to be left with is this product. And the number that we get for this is 334 newtons. Okay? Now that we have the parallel component, the magnitude of the parallel component, we can use the Pythagorean theorem to find the magnitude of the perpendicular component. Plus f perpendicular, the magnitude of the perpendicular component. And once we isolate this and solve for this, we get 498.3 newtons. So this was the easy procedure for this question. We have done two other questions like this before. There was nothing too difficult about this question. The only thing that was a little bit tricky in this question was the fact that the unit vector for the axis was parallel to the y-axis, which meant that it only had one component, and that component was in direction of the y-axis. And once we found the unit vector for this along this axis, we came to know that it was only negative 1j. And what this specifies is that the unit vector is basically of the magnitude 1 pointing in the negative y direction. And so we took the dot product of this unit vector with the force vector, and we ended up with our parallel and perpendicular magnitudes for the components of the force. Thank you very much. See you in the next video.